When I found so astonishing a power placed within my hands, I hesitated a long time concerning the manner in which I should employ it. The materials at present within my command hardly appeared adequate, but I doubted not that I should ultimately succeed. I prepared myself for a multitude of reverses, nor could I consider the magnitude and complexity of my plan as my argument of its impracticability. It was with these feelings that I began the creation. Mary Shelley, Frankenstein. My name is Dennis, I'm from GitLab, and today here I would like to talk to you about Frankenstein-monster. But not the monster as depicted by Mary Shelley. Instead, I want to talk to you about monsters that depict our projects when they reach the point of migration, and even more so after the migration has started. There are a lot of talks out there telling you how one company migrated a project A to a framework B and how successful it was. I'm pretty sure everybody have heard at least one of these talks. But how often after hearing to one of these talks, you had the eureka moment saying, wow, now I do know how to migrate my project to that particular framework B. Unfortunately, this rarely happens. At best, we know how to migrate exactly that project A to exactly that framework B. And if you think that I squashed not one, but 3 stories in this talk to address exactly that problem, I have bad news for you. This talk is not going to be any different. You still won't know how to migrate your projects to a particular framework after hearing this talk. But instead, I would like to discuss with you a little bit unexpected look at the matter of migration. And maybe, just maybe, after hearing to this talk, you will know how to migrate your projects to any framework instead. But before we begin, let's figure out whether we are in the same boat. Let's find out what is migration. When we say migration, usually we mean something like this. We take our monster, we apply some magic, and the outcome is Prince Charming. So migration is the process of converting something that we already have to something that we would rather have. Unfortunately, in real life, migration works a bit different. We take our monster, we apply some magic, and the outcome is still resembling our monster. It somewhat resembles the prince, but is definitely not charming. Today, in today's talk, I would like to talk with you about this magic, the glue that takes us from the monster state to the Prince Charming state, what it takes for us to migrate. There are 2 ways to migrate our applications. There is a complete rewrite, and there is a gradual migration. Let's talk about complete rewrite. How many of you think that complete rewrite brings you the best quality project after you've migrated? Wonderful. So as you saw, I've raised my hand as well, just because I sincerely believe that complete rewrite brings us as close to our charming prince state as possible. The problem is that this sort of migration is suitable only for small/personal projects. Companies owning medium and large projects usually cannot afford this type of migration. They either lack time or resources or money, and maybe even all of this. But even if a company can afford this type of migration, usually they don't realize how deep is the rabbit hole they're about to enter. Chapter number 1, rewrite, rewrite, deny. This is the story about complete rewrite of an application, about coffee machine, and everything related to this. Several years ago, I joined the team that was about to migrate their ASP.NET application to something more front-ended, to have better separation between back-end and front-end technologies. And the end goal was to migrate to something more modern and flexible. When I joined the team, I was the only one front-end developer, and as in any company with just one front-end developer, my tasks were very vague and broad. But essentially, they were looking like this: refresh design, whatever it means, pick target framework for migration, and then, of course, implement the migration. Prior to joining this company, I had experience with web design, so refreshing the design was not a problem for me. I also had experience with Backbone.js, and that's what I picked as the target framework for this migration. But I had exactly zero experience migrating front-end applications. So absolutely naturally, I said, yes, of course, I can do that. Why not? The problem is, or rather, the reason why it was so easy, because frameworks of that time had nearly zero overlap in implementation, and pretty much any migration was complete rewrite back then. I was very excited, and so the process began. Backbone.js, Marionette, Foundation, etc., etc., etc. Fast forward 1.5 years, the migration was still not finished. We were very, very close. We migrated nearly all the functionality from old ASP.NET application. We did complete redesign of the project because there is no such thing as refreshing the design. But there was one big problem: the ever-growing list of features to implement in the new system that were not the part of the original scope. So while working with this backbone application, we had to not only account for migrating the existing application, we also had to fix bugs in that application, in that functionality. But also we had to account for implementing the new functionality that was not in the original scope. Absolutely naturally, all of these requests came in mid-process, completely unexpected, and the system just wasn't ready to welcome everybody. So after 1.5 years writing backbone application, we came to the conclusion that it's time for us to migrate our not even released backbone application to something more modern and flexible. This time we picked Polymer as our target framework for migration. Long story short, the feature of using and of adding and removing components as we go was very welcome for that particular project. And then only 4 months after, we were able to release the completely rewritten application with Polymer. But in general, it took us a bit over 2 years to completely rewrite our application. So you understand the problem in full. During all this year, during all this time, the existing ASP.NET application was up and running untouched because everybody was waiting for this nearly done application that has never been finished, really. Nevertheless, we migrated, we were happy. But then in 2017, I lost my job. Well, lost is a dramatic word, right? Let's put it this way. I rejected an opportunity to migrate this application yet another time. I remember talking to my manager by the office coffee machine. It was just small talk, and he casually asked me, what do I think about AngularJS? And it's like, and half kidding, half serious as I usually communicate, I said, come on, man, I'll just quit the moment we decide to migrate it once again, especially to AngularJS. And again, it was a small talk. I forgot about this, but not my manager. A couple of months later, our company decided to migrate our application to AngularJS. And for this purpose, they hired the whole developers team from abroad. And obviously, there was no place for me in this journey. But no hard feelings. We are still good friends, even with my manager. I even come to the old office from time to time to chat with my ex-colleagues about different things. But there is one thing I keep in mind. If you are a Norwegian employee, be careful with what you say by the coffee machine. Because it's totally possible to hire the whole developers team from abroad for salary just of one Norwegian employee. But there were much more tangible outcomes from this experience, of course. First of all, as it turned out, complete override is never just a rewrite. It's always a new project. And if you're lucky enough, it's the project with better defined scope, but not guaranteed. Complete rewrite is much more than the eye meets, because the old application is still up and running while you're rewriting your application. So possibly you miss new customers, and your old customers are irritated with the process. You never account for all the new features that you have to implement in the new application. And new application means new bugs that you cannot test gradually. You put this application as a whole to your users to test. But there was one interesting observation. Web components in this project worked even outside of web components-driven project. The main website of the company was written with WordPress, and we managed to reuse these web components written with Polymer in that WordPress site. And that was really interesting experience. But getting back to our complete rewrite, I still believe that, with all that being said, I still believe that complete rewrite brings us much closer to the ideal state of migration, quality-wise, but it's just not suitable for projects larger than something very small. If your company owns medium-sized project or even larger, you have to consider another type of migration, gradual one. And before we start with this one, I think that all of us who come to the front-end world, and especially to the JavaScript development world, we all have to be a bit masochistic, because there is so much pain in this industry. There is so much frustration, stress, depression. And when it comes to depression, psychologists differ 5 different stages of depression: denial, anger, bargaining, depression, and finally acceptance. We've already heard about denial in our first chapter. Now, let me skip the middle part and go all the way to the end of this list in our chapter 2, acceptance. This is the story about irony in life, uncontrolled power spoiled by hourly rate, and my first experience of making 2 completely different frameworks work together as one in the same project. I would like to start this with something very optimistic. Like several years ago, I decided to quit my permanent job because it was limiting my freedom and start the freelance career because I wanted to pick the projects I want to work with, right? That's how I present this story to the hiring managers, but you've already heard the first part and know how I ended in the freelance world, right? So I rejected a migration to AngularJS, right? And then the first project I was contacted by as a freelancer, I was really lucky. It was a project called Mindstack. This is a New York-based startup company with absolutely fantastic management that gave me all the freedom I wanted. Frankly, much more freedom than I deserved back then. I really enjoyed the product. I really enjoyed the project. But there was one minor problem with this project. Now listen carefully. You're about to witness the true irony in life. After rejecting migration to AngularJS, the first project I was about to join as freelancer was written in AngularJS, of course. But there were 2 things different this time. First, I was get paid by the hour. So technically, I could make Mindstack pay for me learning AngularJS. How cool is that, huh? But it just felt a bit wrong, both for me personally and for the company, especially considering the second difference. Management of this project didn't push me to work with AngularJS. The tasks I was getting were, as they have to be in any startup company, were absolutely framework-agnostic. I had to develop features that work in the existing project fast, but so that it would be easier for the project to migrate to something more modern and flexible in the future. How cool is that? Among those initial tasks, one was particularly interesting to me. I had to develop a container to be placed in a document so that it would be possible to contain any complexity visual theme within this container so that this visual theme doesn't break the styling of the surrounding document, while surrounding document with its own styles doesn't break the visual theme within this container. And for anybody who has been in the industry for at least a couple of years, this immediately should ring the bell. This is the pattern of Shadow DOM. And Shadow DOM is the part of Web Components technology set. So that's the reason why I didn't reject an opportunity to work with AngularJS this time, but happily accepted this because I could keep working with Web Components, deliver the features fast, and set the basis for future migrations with really components-based solution. There was just one question to answer, right? How to make AngularJS project speak Web Components that were written with Polymer. How can we make them work together? There were several stages of this integration, but the last one that we were settled on worked like this. We had components both on Angular side and Polymer side. The difference was that only the Polymer components were functional. They were doing the stuff. Components on the Angular side, instead, were working just as the wrappers. They were wrapping around the functional Polymer components and set them up with properties so that Polymer components would not need to get to Angular scope and get properties. So scope properties were set on the components. And then when a component on the Polymer side had to update something in the Angular scope, Polymer component would dispatch an event, a custom event, and those components on the Angular side would listen to these events and update the scope accordingly. Worked great both for me and for the company because I could deliver value for the company from day one simply because I could use the tools that I got accustomed to. This way of gradual migration that we had showed to be proved us that we can be very productive with gradual migration. But there were some other outcomes here. First of all, I've learned AngularJS after all. That was inevitable. But again, observations about web components in this case. In this project, web components proved to be great containers. They could contain data of any complexity. They could lock it down really, really well without interacting with unnecessary parts of our project. Also, web components proved to be quite the polyglots. In the first chapter, I saw web components working in web components-driven project, also in the WordPress project. In this project, I saw web components speaking Angular as well. So I was really, really excited about this. But there was one problem. Not everybody works with web components, surprisingly enough. When I joined the team, I was the only one working with web components, and the rest of the team was still working with AngularJS. Over time, they gradually started getting there, but it took some time. So technically, if I would quit the project in the middle of the process, all the functionality that I was responsible for would have to be rewritten by the developers working with Angular in order for them to support this and maintain that functionality. They could not leave it on web components. So I started thinking, okay, this is not really good for any sort of project, right? To have this bottleneck in the project. And while working with all these integration stages of web components in Angular, seeing web components speak different frameworks, I've got a very wild idea. What if, since web components are such polyglots, what if we could use them in order to somehow to make completely different frameworks that are not web components based, so that we could have more people working with them. So not web components based frameworks work together in the same project as one well-orchestrated body, just like Victor Frankenstein did in Mary Shelley's book. Ladies and gentlemen, fasten your seatbelts. We're about to hit the bumpy road. Chapter 3, Adventures Begin. This is a story about quite practical implementation of a very crazy theory that I, at first, enjoyed very much, then nearly gave up on it, but at the end it proved to be very practical. In this chapter, we will finally get a chance to build our first monster. Monster in the context of Frankenstein migration. How many of you have heard about Frankenstein migration? Could you raise the hands? Wonderful. That's, oh, one person. Okay, that's great because, you know, that's actually weird because I came up with this term specifically for this talk. Frankenstein migration really doesn't exist. It does exist now with this talk, but not before. What is Frankenstein migration? This is technically the way of making two completely different frameworks, non-web components based, to work together in the same project and work seamlessly. The essence of this way of migration is related to two technologies, first of which is microservices. In essence, it's the way of architecting your application so that you have one container that is dedicated to solving one particular problem. And then such containers get connected into the network of containers that are called services. And that's why the architecture called microservices. This is a very, very well-known thing for backend developers and for the server architects. But what does it mean when we talk about microservices architecture on the front end? The answer can be found in the definitions of a service in such architecture. The service has to be small in size, bounded by contexts, built and released with automated processes, autonomously developed, and independently deployable. So the first 3 points are absolutely no problem for modern front-end frameworks. Any framework can solve this. The autonomously developed and independently deployable points were nearly unreachable for modern front-end frameworks. Because even if a framework like React or Vue provides you with a paradigm of a component, those components cannot be truly independent. They are still very tightly coupled to the framework they are built with. There is only one true type of components that allows this level of independence. You've guessed it, web components. When we talk about web components, usually what we mean is something very small and reusable, like a button or input field. That, in general, is a leaf element of our large DOM tree structures, right? But this doesn't set the limitation for using web components. Because web components can be of any size. Just like our React or Vue applications can have just one DOM element in their index.html, the same way we can build the web components application with just one custom element that would contain the whole application in it. So web components and microservices are two core technologies for Frankenstein migration. Let's get a bit into the theory of process of this migration, how we process. So let's imagine we have this very simple application, nothing fancy. We are going to migrate it to something, to some new framework. We are not satisfied with the framework we are using now. What framework we migrate away from and what framework we migrate to doesn't really matter. The process is going to be exactly the same. The first step in Frankenstein migration is to identify your microservices. Once again, microservices are small and usually dedicated to one feature, one problem solving. So if your current framework supports components like Vue or React, then you're probably good to go, because those components can work as services as well. Usually components are built with one purpose in mind, right? If you don't have those components, if you're on the legacy, for example, jQuery project, then you need to turn on your imagination and split your application into this small, like not really reusable, but small one-purpose blocks. Just like this, for example, or like this. Doesn't really matter. Splitting into microservices is a very subjective matter. What works for you works for microservices. But once you did this, once you structured your application, you forget about the visual implementation, and we talk about these blue blocks as the black boxes, where we don't know what's going on inside. So these black boxes that are blue now, we will be using blue color to mark the containers or services written with the framework we are going to migrate away from. And then red color we will be using to mark the components that are written with the framework we want to migrate to. You saw this transition pretty fast now, right? So all the blue containers get all red. This doesn't happen that often in real life, because this is already, when we have all the red components, this means that we performed complete rewrite. And we figured out that complete rewrite is a very time-consuming process. So it's not as straightforward. So when you get to migration within the gradual migration process, usually this is what you have. 1, 2 components written with the new framework. And you want to somehow integrate them into your existing system. So let's split these things for now. And for the sake of the further discussion, let's call the system with the blue rectangles our host, because it hosts our current system, the system that we are about to migrate away from. And system with the red rectangles, we will call alien, because alien will inject its components into our host system. The reason they are split on the screen now is not a coincidence, really, because they truly have to be completely independent. We are trying to follow the microservices architecture, and this means that host should not depend on alien, and alien should not depend on host. They can be different folders somewhere on your file system. They can be different domains, because we want to make sure that both host and alien are autonomously developed and independently deployable. The only thing that we have to keep in mind is that host has to have access to alien. They should not be dependent on each other, but host has to have access to alien. If these are two different folders on your file system, then host has to have access to the folder with alien. If these are two different domains, you have to make sure that host domain has access to alien's domain and assets on that domain. But once you establish this connection, the question is, how do we implement our alien component into our host system? And that's where web components get into play. We are going to use web components to write the wrappers, not the functional components again, just the wrappers. What do they contain? They contain the reference to alien component. So import of the alien component. And then it's just a matter of replacing host component with our web component containing our alien component. Over time, you eventually write the new component with your new system, right? And the process is the same. You wrap it with web component and replace the host component. And over time, you might get to a situation when all of your host components got replaced with web components containing alien components. It doesn't look very pretty, right? So we could leave it like this, but it's very not beautiful. So The question is now what? How can we solve this in a pretty way? The solution is pretty trivial and very elegant. The HTTP requests that get to your host with just one line of configuration on your server should be directed to alien instead. That's why it's very important to keep these things completely separate. They should not interchange. And once you start redirecting your HTTP requests to your new alien system, your alien becomes your host. And in this case, we see that all of our components got read. That's what we call complete rewrite. So technically, Frankenstein migration is the way of migrating your applications where you get quality of complete rewrite with delivery speed of gradual migration. Let's sum it up a bit with numbered bullet points because I know it might be a bit confusing. The first step in Frankenstein migration, identify the microservices. Number 2, allow host to alien access. You have to keep them separate. Number 3, write alien component. Then you write your web component and import alien component into your web component. Last but not least, replace your host component with your web component. And over time, when you repeat steps 3, 4, 5, 6 for as many times as the number of components you have, you get to this situation when all of the components in your host system got replaced. And now it's just a matter of switching your host, your server configuration, and your alien becomes your host. So you got fully rewritten application without all the mess that is usually associated with gradual migration. Enough of the theory, right? Let's get to practice. Now it's going to be hot. As a practical example, we will be really migrating one application. What application will it be? Very boring to-do application, I'm sorry. To-do application from To-do MVC project. I myself hate when people show new technologies or new concepts using to-do applications. But in this particular case, I believe it really makes sense because we all know how to-do application works. So there is no room for uncertainties or under the hood magic. And at the same time, it contains just the minimum number of components to show you some nuances of the Frankenstein migration. Okay, we have this to do, but we need to figure out what framework we migrate to what other framework we migrate, right? For this example, I picked the legacy path. We are going to migrate to-do application written with jQuery to something more modern and flexible, like React. We already saw how our application looks like with jQuery. What is our final destination? This is how application looks like with React. So we update the styles because, refreshing the design should be the sign of migration because otherwise people would not know that you have migrated. But not only this, it also has a bit extended functionality. So we mess up with the user experience by this jiggling, but at the same we fix user experience with the tooltips coming from Twitter Bootstrap or like regular Bootstrap now, right? This is our final destination. Also, both React application and jQuery application are connected to the same store working with local storage. You need to establish the communication between this, and usually this happens through the shared access to the store. Now, you don't need to remember or write down or take photos of the code you'll see on the screen. It will be shown purely for illustrative purposes. What we're going to talk about is publicly available at this URL. This is called Frankenstein demo. And you can find all the code you'll see. Yes, you can take the picture of this one because this is important. So with that out of the way, let's get to actual migration. Let's get straight to business. Here is our application. Anybody remembers step number 1 in Frankenstein migration? Yes. Identify the microservices. Well, attentive developer can say that this to-do application is already small enough in order to be one microservice, right? But as I said, splitting into microservices is very subjective. So we can split it even further. So let's split it into 2 applications. One is responsible for rendering the header and input field for adding new to-do items. And the second service is related to responsible for rendering the existing to-do items with some editing and filtering functionality. That's it. Number 1 is done. Number 2, do you remember? We'll get it there. Let's talk about the first component we're going to migrate. We forget about the second one for now. So this is our starting point. First component written with jQuery. This is how it looks like on the React side. To use the terminology that we established in the theory part, we will call this one host, this one alien. Blue rectangle for our jQuery, red rectangle for React. We need this terminology because the second point of Frankenstein migration is allow host to alien access. How do we make this if these two things are completely independent, right? Don't worry, I have you covered. You will find a commit about how to add React application as a Git submodule. This is the way I decided to structure this application. So in this jQuery application, I added my React application that was living on completely different Git, in completely different Git repo. I just added as a submodule. So React can still be developed independently from jQuery. In this particular case, both jQuery and React have completely different building systems, completely different configurations for Babel. They do not interact in any way. React can have its own release cycles. But now with Git submodule, I just reference the particular commit of React repo in my jQuery repo. So in this case, React will be identified by our jQuery as just a subfolder, even though it's not a technically subfolder. But anyway, we have full access to this folder. So host to alien access gets approved. Nice. Number 3, write alien component. Since we are talking about a React application that is already done, technically, we can say this is approved. In real life, you probably spend some time writing your alien component. But before we proceed, we need to talk about toolset a bit. What tools do we need to talk about? First of all, you have to have configurable package bundler. And I intentionally don't say Webpack or anything like this, because I sincerely believe that the configuration that we implement in this project are so subtle that it's very easy to map them to pretty much any bundler of your choice, as long as it's configurable. So what does it mean? If you are migrating from React, and your React application has been built with Create React App tool, then most probably you need to eject before you do things. You have to get full access to configuration of your bundler. And this has to happen on the side of the host. The another thing, web components polyfill. But whether you need this or not is a big question. I'll just show you the support chart now. So these are two parts of web components technology set that we are going to use. Custom elements and shadow DOM. This is the support per today, but you see the asterisk next to Edge. From Edge version 75, that is the first one Chromium based, these things are natively supported. So if you do not need to support IE11, you can easily leave without polyfills for web components. Web components are here to stay. But if you need to support the browser or any specific mobile browser, because there are some mobile browsers without support, like Opera Mini, for example. Here is the information for to read more about this polyfill, and this is the next link is actual download link for or link to the repo of web components. So with these tools, we say, okay, we have all the tools we needed. Now we're getting to the point 4 and 5. Write web component and import alien into web component. So they are kind of very tightly coupled. So let's combine them, because writing web component without importing anything into it doesn't really make sense. And of course, I have you covered. There is a commit for that. How we do add the thing, how we write the web component and import the alien component. But in essence, here is what happens there. This is all it takes for the wrapper component, really. This is all web component you write. And there is no magic here. It's very simple, standard way of initializing web component. You attach the shadow DOM to your root element. Then you define the custom element in order to be associated with this component, right? The interesting part happens here. We import everything React related, and then we render our React component on the mounting point within our shadow DOM. The interesting thing to note here is that all the things React related are not imported from the current jQuery folder. They are imported from our React subfolder that is completely independent when we talk about Git repository, for example. That's why this is very important that host has access to your alien system, because we will need to import the things. We do not want to install React into our jQuery project just to be able to import things from React. So we import everything from React here. By the way, yes, so this point gets approved. We have web component, but if you want to use any sort of abstraction layer for writing your web components, like Polymer or Lit element, you're free to do so. It's just for this type of wrapping components, I think it's an overkill to get the full size system, because the components are so simple. So number 4 and 5, we have web component, we have alien component imported into the web component. Now we have to replace host component with web component, right? The question is, can we do it right now? If we do it, if we replace the existing markup in the jQuery application and replace it with the web component that we just have just defined, we'll get the error, obviously, because we're importing and browser doesn't know how to work with ES6 imports. So we need some magic, and I have you covered. We need Webpack and Babel configuration for our jQuery application so that it would know how to work with those imports. You get there and you get the information about how this is done for jQuery in particular. But in general, this is the thing. The Webpack configuration in that commit, there's also a custom CSS loader and other nice things here. But what it essentially does, it introduces the new entry point in Webpack configuration that is responsible for bootstrapping all the Frankenstein related stuff. And then in our index.html of jQuery project, we reference this entry point just as a script. And after that, it's as easy as just replacing the existing jQuery markup with our web component. Now we are ready to witness the magic of React component working in our jQuery application, right? Right. Technically, we do have React component, right? But it looks weird, to say the least. It lacks styling, but not only styling is the problem. If we try to add a new to-do item, no matter how often you click the enter button, your local storage doesn't get updated. What's the problem? As I said, we have two problems, right? We are missing functionality and we are missing styles. This is not a very good thing to find out when you migrate an application. But let's tackle them one by one. We start with functionality. No matter what React documentation tells you, React doesn't like web components. React hates shadow DOM. The reason is all these DOM events, like on-click, on blur, on whatever. These events do not propagate to React when a component is within shadow DOM. In order to fix this, we need to retarget events. Fear not. Smart people talking on Stack Overflow and Lucas Bombach, I'm sure I mess up his name, I'm sorry, but these people do love web components and they provided some solution for us so that I could have you covered with this commit, retargeting React DOM events. You will find all the information about how to retarget events from your React components being placed in the shadow DOM. When we work with this commit, when we're done with this commit, we check the functionality and now our local storage gets updated. So now our events get propagated properly to React. The problem was that enter on key press event didn't fire up in React before this. Now it does. So we have our functionality back, but we still have application styles missing, right? Let's talk about styling for a bit. There are several ways to style your documents: global styles, CSS modules, style scope. The difference in these different ways of styling documents is the area of application that they cover. So global styles style the whole document. CSS modules and style scope style the components. Who believes that CSS modules provide you with adequate encapsulation for your components? CSS modules. That's really great, because CSS modules do not provide encapsulation. They provide scoping, just like scope attribute. This means that when you write CSS module, you can make sure that the styles from your component do not leak to the outside document, right? But nothing prevents styling coming from global styles scope get into your component and break all your CSS modules just easily without even too much work, just higher specificity, that's it. So CSS modules and style scope do not provide encapsulation, they are about scope. What does provide encapsulation? Shadow DOM. The problem arises exactly because of shadow DOM, the missing styling that we saw with React component. When we put component within a shadow DOM, it provides proper encapsulation. So it locks the component from leaking the styles to the outside world, but it also locks the component from getting any styles from the surrounding document. There are only inherited styles like font family and some azimuth and some random other things that get into the shadow DOM. The problem is when global styles try to style a document, they just get bumped out of shadow DOM area. That's great. That's what makes shadow DOM and web components really reusable. We can use them in any environment, right? But when it comes to CSS modules as the required or recommended way to style React components and Vue components, for example, then we have a problem because they are not standards. They do not exist and they do not really come with your component when you import your component, because they are just package bundler dependent. So essentially, when you have your component in Vue or React with CSS module, it's dependent on the bundler. And what bundler does is extracting those styles and create, like mangling with the class names and puts this style sheet as the global style sheet in the head of your document. It doesn't come with your component. That's why we miss the styles in our shadow DOM-based components, because the styles for those components are in the head of our document, and those styles do not propagate to the shadow DOM. What's the solution for this? I told that React doesn't like web components, but Vue does like components, web components, and shadow DOM in particular. With Vue, it's as easy as adding just one option for your Vue loader and Vue style loader to tell those things that you want your styles to be injected in relation to shadow root, not the document's root. Not the case with React, unfortunately. So with React, we need to make sure that we somehow inject these styles into our shadow DOM. Don't worry, I have you covered. This is the commit styling header React component. And with that, I say that we are done with styling, because this is how our jQuery-driven component looks like now. If we take a look at the code here, so we have our Frankenstein header component. This is the web component. And then we still get the jQuery code because we didn't replace the second part of this application yet. But in this Frankenstein header component, we have our style with all the styles, and the rest is just pure React. Can we say that replace host component with web components works? Yes, it does work. We can inject our React component into web component, and the web component can be injected anywhere we want. So we have to rinse and repeat for as many components as we have, and in our case, it's just one component left. The problem with the remaining component is, you saw that jiggling when I showed you the React application at first, right? And the tooltip with Bootstrap. Those things won't work out of the box again. Because if you are using any jQuery related functionality in your alien component, any jQuery plugin like Bootstrap, for example, or your custom jQuery, this type of initializing or setting up the plugins will not work. This is the typical way we set up jQuery plugins, because these things, just as our global styles, they do not get into the shadow DOM. So jQuery doesn't see the components you want to attach functionality to. So we have to opt for an optional argument when you deal with jQuery. If you really need to use jQuery in your alien components, you need to supply this second argument. And this second argument should be not your document, but your shadow root. And then your functionality gets into the component. At the end, this is the result that we've got. We have both components. Probably you see it like this. Frankenstein header component on the top, Frankenstein main wrapper at the bottom. And they look exactly as our React application. They even function as React application. And now with all this fancy jiggling, and even the Bootstrap tooltips do work here as well. This is driven with jQuery still. So it's jQuery application with component, with React components in it. So now the only thing that is left for you is to switch your HTTP requests to the new system. So what is my Frankenstein migration? First of all, it's not a holy grail. It has a lot of issues. It's not a silver bullet or whatever you prefer to call something that solves all your problem. It's an experiment yet, but it goes well beyond the migration only. So it would be only correct to call it not migration, but the approach. Because if you're a developer, you can use it in order to bootstrap or prototype your project with using components from different projects you had previously on different frameworks. If you're a project manager, you can think about this as branching out your core functionality out of your project and put it on the faster release cycle. For example, your core functionality can be released every week, while the main application can be released once in a month. And then you just reference in your main application, you reference the production version of your core component, core functionality component. And you're done. You can release your core functionality without rebuilding the whole project. You can think about this if you are even hiring manager, because this allows you to do framework-agnostic hiring decisions. You do not need to find people primarily working with your framework. You can find smart people who can do things in a smart way, no matter the framework they are using. So I would like to ask you to get to these two repos. This one, to Frankenstein to do MVC, this contains the code for different frameworks prepared for Frankenstein migration. This one, Frankenstein demo, this is the repo containing different directions of migration. So jQuery, you will find migration, jQuery to React as the branch here. And this one, you will find branch as jQuery or React or Vue. Please, do create things and do not be afraid of your creatures, as Victor Frankenstein did in this book. Thank you very much.
That was incredible. Wow.
Thank you.
I think the internet was impressed by that because we have been flooded with questions.
Oh, wow.
We've only got a couple of minutes to do those.
Yeah, I'm sorry I ate some time for questions because I knew I cannot answer probably more than the half of those.
A very clever technique there. I approve of that. One of the big ones we've got a collection of questions centered around performance.
Right.
And does this result in duplication of assets, libraries, and such?
That's a very, very good question because, of course, it does. If we do not keep an eye on this, it will. But since everything, it can bring problem with performance in regards to styling because we might need to duplicate styling in different components. But that's up to you to decide how you structure your, in this particular case, Webpack configuration. You can cache those things, and then you will just have nearly zero penalty, even from duplicating the styling. Also, a good tip, when you migrate this way, in order to not create the performance bottleneck, make sure you you start with one component, and the next component you pick to migrate is next to this one, so that you could frame them into one web component. Instead of creating two different ones, you create one alien component, and then the new one has to be next to it, so that in the web component, you can frame them and import the styles just once for both of the alien components. But yes, the problem might arise. You should keep an eye, but Webpack allows to cache these things properly and do the tree shaking if you need to. Yeah.
Okay, right, we're up for time. Give a huge round of applause again for Dennis, please.
Thank you.